lab is an experiment on acceleration of a cart, and it's going to also involve Newton's laws, okay? And we're going to do this experiment the next day or so. Okay, the setup of this experiment's like this. We've got a cart, which is red, which is attached to a string. And the other end of the string goes over a pulley and down off the table, and that is attached to a weight which is hanging off the table. Okay, I'm going to call that weight M for mass, okay? The cart is going to be pulled off the far end of the table, okay, or it's going to be pulled to the far end of the table, and it's going to be let go. So when we let it go, this mass is going to fall, okay? It's going to fall toward the ground, and it's going to accelerate toward the ground with the acceleration of, it would normally accelerate with the acceleration of gravity, right? Okay, which is 9.8 meters per second squared, okay, downward, okay? That's how it's going to accelerate, okay? And while it's doing that, we're going to measure the acceleration of the cart using a ticker timer. Well, that's this little black thing right here. And basically what's going to happen is there's going to be a little piece of tape that goes through the cart, attached to the cart, goes through the ticker timer. And then as the cart moves, as it accelerates across to the table to the left, the tape is going to go through the timer. And every 60th of a second, there'll be a dot put on the ticker timer. Okay? So you can see how this is going to work, right? So let's talk about a few questions about this thing, okay? So let's go back, and I'm going to do a couple questions. Okay, so I talked about this part at the top. So let's talk about these questions. If the mass of the weight, the mass that we're going to use here is 500 grams. Okay, this is 500 grams. Okay, and we're going to change this acceleration of gravity. We're going to change that. The acceleration of gravity we normally use is minus 9.8 meters per second squared. Well, we know that there's 100 centimeters in 1 meter. Okay, so we can cancel out the meters here. And if we multiply this through, this is going to be minus 981 centimeters per second squared. That would be the acceleration due to gravity. Okay? Okay. So if we knew that, then what's the force provided by the weight when it's in free fall? Okay? So we want to find the force provided by the weight. This is the mass. Okay, and that's 500 grams. And the acceleration is going to be 981 centimeters per second squared. We want to know the force. Okay, so I'm going to calculate that. Okay, so let's go back. Okay, so what I'm going to do then is say, okay, the mass is 500 grams. These are my givens. Okay, and the acceleration is minus 980, this downward, right? It's downward. 981 centimeters per second squared. Okay, so I want to find out the force provided by the weight when it is in free fall. So force net equals MA. Okay, and that's going to equal, and I'm going to change the units of this to different units than we normally use. This will be 500 grams. Okay, and then the acceleration is going to be minus 981 centimeters per second squared. And so if you multiply this out, it's going to be a big number. It's going to be negative because it's down. The force is downward. 490,500 grams times centimeter per second squared. So those aren't newtons. Okay, that's not a force in newtons, right? Okay, but that's the force that would be applied. Okay, and so and I'm doing that in these units right here. Okay, now let's go to the second question. So we've now calculated this force. Now we know the force. Oopsie, here we go, gotta go back. We now know the force downward. Okay, the force applied downward on the cart. Okay, and that's going to be a downward force. Okay, and so we know that, and that's minus 490, 500 grams, 490,500 grams centimeters per second squared. Okay, and we're going to use Newton's second law to solve for and record, and so we're going to use Newton's second law to calculate the acceleration of the cart. Okay, so now the interesting thing is we also have to know that to get this whole system, the whole system is the mass of the weight. Okay, it's the mass of the weight, and it's also the mass of the cart. Okay, and we'll say the string, we're not going to worry about the string. Okay, but so we're just going to do the mass of the weight and the mass of the cart. And so if we do that, this problem tells us that the cart and the weight have a mass of 1,900 grams. Okay, so it must be that the cart has a mass of 1,400 grams, right? Because we know the weight, right? Okay, so let's solve for the acceleration there. So we know, this is 490, 500, that's the force. And of course, we're solving F equals ma, right? So we know that's the force. I'm going to leave off the units for simplification. And then we know the mass is 1,900 grams. Okay, and we want to solve for the acceleration, a. Okay, so if we divide these two, what we get is an acceleration equal to 258 centimeters per second squared. Okay, and by the way, this is going to be negative, isn't it? It's accelerating downward. Okay, so that is downward. Okay, the negative makes that downward. Okay, so I'm going to take that negative off there. See if I can take it off. There we go. And that becomes 258 centimeters per second squared downward. That's the acceleration. Okay, so this prepares you to do the lab, because doing the lab, you're going to do the same calculation again, but you're going to use your actual results. Okay, so let's talk about that in a few minutes.